In this next problem, we have an implicitly defined function, or an implicit equation. X plus xy plus 2y squared is equal to 6. So we start off by taking the derivative of both sides. Derivative of x is 1. The derivative of xy is a product, and so that'll be 1 d2, so xy prime plus 2y d1, which is 1. Then the derivative of 2y squared is 4y y prime, and that equals 0 on the other side. So I'm going to group my y primes together, move everything else over. So I get y prime times quantity x plus 4y is equal to negative 1 minus y. Well, y prime is negative the quantity 1 plus y over x plus 4y. So that would be the answer to part 1, or part A. For part B, we want to write an equation for the line tangent to the curve at the point 2, 1. Well, we know our x sub 1 is 2, our y sub 1 is 1, and our slope we will get from the derivative by plugging in the numerator y is 1, so we'll get negative 2. The denominator x, which is 2, plus 4 times 1, which is 6. So we end up with negative 1/3, and the equation would then just be y minus 1 equals negative 1/3 times the quantity x minus 2. So that's part B. For part C, we want to find the coordinates of all other points on the curve. That have the same slope, that have curve with slope equal to the slope at 2, 1, which means negative 1/3. Since the slope is negative 1/3, we set the derivative equal to that, and the negatives will cancel. We cross multiply, we'll get, so we get 3 plus 3y is equal to x plus 4y. Probably want to isolate the x here, would be the easiest thing. And we get that x is equal to 3 minus y. So what we do, we can't stop at that point. What we need to do is take this, plug it back into the original function, and solve that for y. So we would have x, or 3 minus y, plus 3 minus y times y, plus 2y squared, and I'll subtract the 6 from both sides. Minus 6 is equal to 0. When we simplify, we get y squared minus 2y minus 3 is equal to 0, which we factor as y minus 3 times y plus 1, giving us the zeros. Y is equal to 3, and y is equal to negative 1. Now we have the y equals 1 above there, in the previous problem. So we want to find the other slope, which is going to be, well, in this case we can only have one value at y equals 1. Actually, I made a mistake here. It should be y squared plus 2y minus 3, so that our solutions would be y equals negative 3 and y equals positive 1. And that corresponds to what we had in the previous problem. We had x equals 2, y equals 1. Since x is not squared here, it's impossible that we would have two values at y equals 1. So all we need to do is plug in y equals negative 3, and we're going to end up with negative 2x plus 18 equals 6, negative 2x equals negative 12, so x is equal to 6. So we would have the point 6, 3, where the tangent at that point would also be negative 1/3. And you can plug the x equals 6, y equals negative 3 back into the derivative function just to double check that. That would give 2 over negative 6, which is negative 1/3. Alright, so that is part C on this one.